Excellent. So I'm Sam. I'm a product design engineer and the co-founder of Informal. And I'm going to be chatting today about kind of the background of what product design engineers do and the two case studies that we have of products that we've worked on, one silly and one serious. Quick background on me. I am born and raised in Massachusetts. I had an internship designing these really interesting robots called Kiva Systems robots. They were acquired by Amazon. They move giant pallets around and shelves around so that people don't have to run down these giant warehouses to grab your items and ship them to you. That's where I learned about engineering. I actually went in to become an electrical engineer and left that internship realizing I wanted to be a mechanical engineer because I like seeing when things aren't working. I went to the University of Vermont. I'm up here in Burlington now, but this is where the UVM is, and I had a degree in mechanical engineering. And when I graduated, all the smart kids got jobs, and I was not one of them. So I had to leave the state. And I got a very interesting job outside of college in Brooklyn, New York, working at a company called MakerBot Industries. I helped design and develop 3D printers and accessories in that world for 4 years. And MakerBot was kind of the darling of the 3D printer industry. They were coming off of this very successful DIY plus product and trying to make more of a consumer product. And that's where I joined the team, and they threw me in the deep end. My job was injection molding, die casting sheet metal, working with factories both domestically and overseas. And I really enjoyed working directly with industrial designers as that glue, that middle layer between everything. Spent 4 years there, worked on a handful of great products, and then left to work at a startup called Mevo, where we worked on very small live streaming cameras, where I learned even more about consumer electronics design and development, worked with some of the biggest factories in the world, got to go out there to China often, and did that for a couple of years, and fell in love with freelancing and moonlighting, and that's how we landed at Informal. So that's kind of my general path. So a quick overview, a product design engineer is a weird term. I think the spectrum of mechanical engineering is fascinating because, you know, a mechanical engineer can work on aircraft, consumer and military, vehicles, both like professional and consumer again, even HVAC. They all kind of fall in the category of mechanical engineering, but a product design engineer works on products, which is in the name. So things like these beautiful synthesizers or even appliances or toys are more on the product side. And that's where I really like working. Product design engineer, they are mechanical engineers, but I also think of them as kind of the central hub of a product, right? So it's where everything becomes physical. So you work with electrical engineers on the board outline, the component placement. You work with the firmware developers to spec components, IOs, making sure your microphone gaskets are designed correctly. You work with industrial designers to ensure that the product form can be mass manufactured, and project managers on timelines with factories. So everything kind of comes together with a product design engineer, for better or worse. I gave this talk recently at a university, and they didn't know the Power Rangers, so I thought it was kind of fun to leave it in. I had to be like, Power Rangers, like no one knew, but they're, you know, 20 years old, so it makes sense.
They're too young or
too young.
Old.
Yeah, probably both. I don't know what's the new Power Rangers these days, so we'll leave them in. But I think one thing to highlight here is, you know, go from concept to prototype to product. That's very important. A little bit about Informal. We're a very strange company. We're 8 years old, and I'm the co-founder. But we have this network of very, very talented folks. Some are who are on the call right now. And the goal is, you know, we're matchmakers. So if you need a product designed or developed, we can pull from our network, build these amazing teams, and manage them. And these are professional freelancers and consultants who do this because they enjoy having their own life, basically. They don't want to work for another company, right? So they're ex-Apple, Tesla, SpaceX, Google folks. These are people who want to be full-time freelancers and contractors, and we're helping build these amazing teams of the right people at the right time to work on cool projects. So 2 case studies today, one very serious, one could not be less serious. We'll talk about a solar-powered Bluetooth speaker, and then we'll transition into my own fever dream product that I should probably grab and show in a moment. So first, Lodge Sound. I'm very, very proud of this product. We worked on this a handful of years ago, and the client came to us and basically said, I want to make a solar rechargeable Bluetooth speaker that lives outside. He's an electrical engineer, so there were some specs, but basically the high level pitch was like, wouldn't it be cool if I didn't have to take in these speakers every time I'm done having a party? And why am I running all these wires between all my party speakers if there's Bluetooth and good solar? And so our task was to take this prompt and start, defining specs, right? This is what an engineer does, is English language into technical specs, into engineering speak, right? So even from this, like, what does that mean? What does solar rechargeable mean? How long does it take to recharge the battery? How long does the battery last? And then back out, calculations on square inches required for solar panels. Similar with Bluetooth, right? Is this party mode? How many devices can connect? Kind of refining the initial ask into actual specs that we can compare and check off against later on. It lives outside, UV rated, waterproof, things like that. I'm sure all of you have seen this, but this is the typical product design steps. Everyone's got their own version of the image, but basically, what are we making? Let's make it, let's refine it, let's mass produce it, and let's go. Those are the big steps. Typically, a process like this takes anywhere from a year to 2 years to 5. Really depends on how complex things are, how many changes are happening. A Juicero, for example, I took one apart and they had like, I think 15 or 11 revisions of just the injection molded plastic parts. But I would say on average, a product like this takes a year and a half. So step one, discovery. We already started working on our tech specs. We bought competitive products and we started ripping them apart. So, how do other companies create waterproof, high quality party speakers? Best way to find out is buy one and take it apart. Take pictures. From here, we're learning gasket design, drivers and tweeters, board placement, strategies to mitigate water ingress, USB port placement. All these things are really, really invaluable to learn by just ripping something apart for $100. So that's step one. At the same time, our industrial designers started working on concepts. Here's what the product may look like. This is a refinement process you do with the client. Here's 5 concepts. The client says, I like this one, I don't like this. This element looks cool. We mix and match and refine and iterate until we get to the final form. From here, we're still playing with things like color, but that's where I can now say my turn as a product design engineer to really hop in. My job is to break this up into components. So the goal is, how do I not ruin the industrial designer's intent, but ensure that everything can be A, mass manufactured, and B, assembled in a way that is repeatable and testable, right? Like waterproofing. I need to make sure no water gets in. I also need to make sure this doesn't take an hour and a half to assemble. So these are the first passes of, I think we can break them up in these ways. I think we can fasten things from here. And actually, we use this exact strategy, which is always nice to see, from your initial concept to the final unit. Then we go into prototyping. So on the way left is just wire routing. This is where the main circuit board is and the UI board, and how do these wires all connect, and how do we ensure that we can assemble this and test it? And that determines things like your board placement and your component placement. The middle image is just me using graph paper to simulate where a flex FPC cable may run and ensure that we have the right bends and profiles and things like that. And then on the way right, we're using higher end 3D prints to simulate the final assembly, make sure everything fits fairly well. From here, we go into iteration. And again, this is a process. This happens sometimes for years, hopefully for months. You can see on the left, this is the inside of the faceplate of the speaker. We noticed that the speaker was deforming. These things create giant pressure waves, right? That's how they create awesome sound. But as a side effect, plastic needs to be very, very strong to not deform when the speaker's running. If it does deform, you lose audio quality. And so we had to start reinforcing the plastic parts in ways that are not visible to the customer, but internal. And so these little plastic ribs are structural components that we added inside. This is also when a part starts looking real to me, when I'm like, okay, this looks like something I took out of another product. That's a good telltale sign that we might be on the right path. So once iteration's done, you're feeling good about your design, you start moving on to DFM, design for manufacturing. This is a learned skill. I learned design for manufacturing by designing parts and getting told that I couldn't do it, that it was wrong. You get better and better each time. So typically, oh, that's cool. There's a camera there. Typically what you do is you create documentation. So here's the texture of my part, the plastic I'm using, the specific resin, where the texture breaks are, things like that. You call them all out. Then you work with the vendor, and the vendor will say, I understand what you're trying to do. However, we need to move the ejector pins, or we need to inject the plastic here and not there. And there's too much thickness of the material. So there's always this give and take of, you know, this is best for manufacturing. This is best for what the product looks like. This is best for assembly. And you work with the vendor, and you try and push their limits a bit, and they push yours. And you end up with this iteration again, where the final result is each and every plastic part or metal part or whatever you design has all these things approved. These documents can be 15, 20 pages long easily. Then you work on things like the exploded view assembly drawings, the packaging illustrations. There's, you know, everything needs a file. And then you're finally ready for manufacturing. So these are some of the molds right off the tool. So these are giant blocks of steel that are CNC machined down, and they come together, and you inject them in the plastic, cools and hardens and comes out, right? So these are very expensive parts, these tools. So you want to make sure everything's ready before you invest in it. They just look so cool too. And then finally, I started getting units for beta testing. So I built a handful of them in my garage and beat them up. So that could be anything from looking at the assembly issues, you know, talking to the vendor. They never come out right the first time. So it's always things like, hey, there's a bubble here, and the vendor says, oh yeah, we can improve it with XYZ. We'll send you new parts, and you iterate. But then you test them. And so let's see if these videos load. If not, I can just talk through what they would be. They do not load. Anyway, some of the tests we can perform. We did, let's see. Pairing, so testing multiple speakers at once and making sure that they all played at once. I listened to a lot of Old Town Road, and I'll explain why in a minute. This one was really painful. Obviously, it's slow motion, but you want to see, you know, this speaker is really heavy, and what happens when this mass is dropped straight down? Are we cracking any plastic parts? And the answer was yes. Are we causing damage? And you have to drop this over and over on different sides and simulate, you know, a customer dropping your unit, which is going to happen. You don't want it to just explode. And then this one, I don't know what this one is, but we do see, I see a question as well. We can get to that. Greg, I'll let you drive questions.
Yeah, let's get a question.
Do you unmute him?
I think so.
Yes, I have a question, Gregory. First, nice to meet you. We know each other, Sam, actually from another location. The question is, what is consideration used for the testing? You only show the video, how it's fallen, but you
Yes.
show, if you can explain more about the procedure, what the procedure of the testing?
Yeah. So there is an ASTM standard, I believe, for vibration, packaging and vibration, and then product drops. And I forget the exact specifics, but I believe it's something along the lines of you define the vertices and the edges and the flat faces. And you want to drop the product on each one of these and test for function in between. And so it's something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 26 drops or something crazy like that. And the goal is you survive it. And it's a certain amount of distance onto a certain material. And you can choose that distance and material. So like a military spec is really high. I think it's like 10 feet onto concrete. Obviously, your iPhone is not tested to that. It would explode. So there's different materials. There's heights. So it could be like 6 feet on the carpet, or, you know, 6 feet onto wood floor. And I forget the exact parameters. But you can actually, when you go to the factories in China, they have equipment that holds your product, and you put a calibrated slab of granite on the ground, and you bring it up to the right height, and it drops, and it opens at the last second so that your product is oriented in the right spot and drops correctly. I don't have that. So what I did is just set up my camera and do some testing. And this is like almost a pre-screening. Am I going to pass this test later? The only way to know is to beat it up. So the factory still does the drop tests, the vibration tests, and things like that. But this is just that first pass of it all. Did that answer your question?
Yes, thank you.
Of course. More testing. So again, this is at-home testing, not factory testing. This is an outdoor speaker. And actually what happened, this is a long video, but basically what happened was we had a leak at my house and I had to put an industrial heater and dehumidifier in the middle of the summer. So it was 120 degrees Fahrenheit and I think 10% humidity in my kitchen, which is basically the desert in Arizona. And we're building an outdoor speaker. So I was really disappointed that we had to do this in my house, but I was also very happy to use this as a instance for testing the speakers. So I had a few in front of this industrial dehumidifier simulating Arizona. And then I would run downstairs and simulate thermal shock by putting them in my beer fridge next to the White Claws. Thermal shock is really important, right? So if something gets really hot and then really cold, you can burp and let air into your gaskets. And sometimes you can get humidity in there as well, and that can cause electrical issues. So obviously no one's like running between a dehumidifier and a freezer and doing this, but a hot day in Arizona and then a cold night, you may have your gaskets burp and draw in some dew or humidity. So we do want to, play it safe. This one I was really proud of. That's the hamster dance, so we can turn that off so no one has to listen to that. But I built a recirculating shower head system that simulates being rained on. And we did something like 2 weeks straight of water immersion where I kind of rotated the speaker every once in a while, but it was running. And the goal was, if we get a constant drizzle, is this going to survive? Later on, we turned up the water pressure and the duration, and then the factory ran their actual tests. But this is validation. Is this, IP66 rated? I don't have the proper test equipment here, so I have to make do with what I got. My family hated me for that test, by the way. Drop test, you can see what happened, right? Like the front housing cracked and exploded. So you need to make that better. We put a block of foam inside, we reinforced the panels. It definitely helps. These fit checks show me, where do we have issues, where parts interfere. So there's a lot of work that goes into just, does it go together well? This I thought was really cool. I love the factories in China. This is the assembly documentation for just putting this metal logo on the grill. That's all it is, but it's an entire page and a half of like, pull the glue off. They made us a 3D printed fixture, the alignment and everything. So every minor detail has, assembly instructions for the worker that they can review and train up on. And I think that's always so cool. And a lot of this goes on, this was during like end of COVID. So a lot of this was on WeChat. And we got images of the factory line. So this is the first units that they made. And this factory I love, they just sent me a video being like, hey, is it cool if we use this glue robot we designed? We'll see if it loads. But basically, they came up with this multi-access glue dispensing robot that they just started using on the production line. And it was gluing this passive radiator gasket on. So I thought some worker was just going to apply a bead of glue and keep going, but they decided to automate it. And I just love that they took that initiative and made it. It was really cool. And then this is that water ingress testing. So, I drizzled it with water for a couple of days. They blasted it with a fire hose, and it survived. So this is their equipment. You can kind of see the speaker in the way at the way back on the shelf. They're getting hit, but it's part of their test spec is the pressure and distance. And this there's that arch up there. That's another test where it simulates different angles of rain hitting the speaker as well. And then not only did we build the product, we also helped them create a Kickstarter campaign and raise money. So my other half, Nate, is a crowdfunding beast, and he helped build this amazing campaign, photo, video assets, go-to-market strategy, such that the client actually made nearly, I think, $650,000 combined with Kickstarter and Indiegogo, which covered our costs for engineering development and allowed him to go forward and pitch this product and make it. So that was always awesome. And then the coolest part is always seeing the reviews, right? So 4.5 stars on Tom's Guide, ZDNet loved it, Forbes loved it, and that's always, critical. So this was the story of Lodge. Things are about to get really weird. So this is a good spot to ask any questions or comments. Hopefully there's no concerns.
I have one.
Yeah.
So I'm curious, the person who came up with the speaker, how would he or she decide whether they do it alone or they hire a professional?
I think this was a case of they couldn't do it on their own. So mechanical engineering, industrial design, branding, marketing, all those are outside of their skill sets. They were an electrical engineer by training, and then I think in the technical sales industry. So they knew how to pitch the product, but they needed help developing it. So it wasn't whether or not they could do it, it was who they used, which is how we came in.
So basically for this complexity of a product, it simply doesn't make sense to acquire the skills.
So I don't think it's possible in a nice way. Each one of these skills, industrial design, mechanical engineering, firmware development, supply chain management, electrical engineering, right? These are hundreds of hours of experts' time that went into it. And that, I think, if you were to learn those capabilities, it would be years, right, by the time this is done. And that's not to downplay this person's capabilities. It's just that, like, you're designing for an action semiconductor microcontroller. You have to lay out that board. It has to pass FCC certs. Your firmware has to be robust enough to receive over-the-air updates. Mechanical engineering has to be injection moldable. All these things, there's very high standards for what you need to make a consumer electronics product. I think, yes, you could build one or two with Adafruit and SparkFun and a 3D printer, but making one or two products is very different than making 100 or 200,000, right? And those are very different skill sets as well.
Yeah, okay, it's actually a very good point. So many times I talk to people who consider doing things alone, and apparently even for small things it's not that easy. Definitely not for anything like this speaker that passed so many different tests. Dear guests, do you have any questions? Anyone?
No, I don't have. Before I ask my question, no, I don't know. I'm a mechanical engineer myself and done all these things similar way for different industries, right? In my life.
All right, Sam. I think then let's talk about the second product.
Yeah. So this was the first one is client getting paid to do it. Now we get to talk about how I'm losing my own money on a silly idea of mine. So a couple years ago, I came up with this idea, and actually, Gregory, this is back to what you were just saying. Like, couldn't somebody do it all? This is my attempt, and I would say almost my failure. So in 2021, we had an amazing client working on a product called Burrito Pop. They're right behind me. They are a device that you put a burrito in, twist up and down, and you can take a burrito on the go with you. Fundamentally silly. People loved it. So Nate and I worked on it with a few other of our engineers and designers. We launched the product in the Kickstarter, helped them build a website, and sold the product. So that was a thing. This was during COVID, and my brain was going bad. And I decided, if this can be done in holding food in a funny way, I wonder what else we could do with it. And I came up with this donut holder. The idea was I could take, I guess in Canada, Timbits. In America, they're Munchkins, Dunkin' Donuts, donut holes, and make a device that I could put on my belt and dispense donuts as needed. And I 3D printed one. It had a rubber band as the spring. And I made one, sent it to my family, and they're like, that's really funny. You should probably get back to work. Then a couple years later, I started revisiting the idea, but a couple things happened. I got married. We moved to Vermont. Had a child, bought a house. So I was a little busy. And all of a sudden it came back to me of like, I should keep working on this for some reason. So last year, right around this time, I created this second version. And the big change was I wanted this like magazine attachment where you could expand the capacity, make different attachments. It was, still dumb. But came up with this second prototype, shared it with my friends. And the feedback was basically, I told them I wanted a pontoon boat. I was going to sell it to Dunkin' Donuts, get some money, buy a pontoon boat. And my friend said, skip the middleman, pitch just for the pontoon boat. I give you the product, you give me a pontoon boat. And that's where the idea came for this crazy website I built. You can visit it, www.dearduncan.com. It's essentially a fever dream. It's my idea of sharing this concept, trading this idea to Dunkin' Donuts for a pontoon boat. Fundamentally dumb. Put it on LinkedIn as an earnest pitch, and it went viral. It was something like 150,000 impressions, a lot of reposts and comments, and people were talking about it, and I was caught off guard. And then it was featured on this blog called The Morning Brew, and something like 44,000 people visited the page in the first couple of weeks. I forgot to ask for emails, so they all went to the website, scrolled, and left, which sucks. But it was also like 5-minute viewing time per person. So I think I did the math, and it was like a month of time was wasted collectively in like a few days, like of just human power. I just burned everyone's productivity.
Quite efficient.
Yeah. And this was a transition moment from like, this is kind of funny to holy shit, should I actually do this, right? Like, made people laugh. People seem to like it. I'd never say no to a bit. And this is when I just committed to it and said, like, I'm going to make this. So step one was improving the mechanism. The previous one, you press a button, all the donuts fell out at once, which is not good. So I designed a mechanism with injection molded plastic parts so that it can index and hold the donuts above it. So when you press the lever, it holds the donuts. When you release it, it drops the next one. That took something like 15 iterations. I started measuring donuts. I started learning about donuts. I categorized them. I watched how it's made videos. I ate a lot of them. And then I started measuring them. And I gathered data. And I ate more donuts. And then I realized, like, this is inefficient. So I actually made a machine that measures donuts. And you put them in, and it weighs them, and it measures 3 axes, and it logs them in a spreadsheet for me. The theory was I would measure enough donuts that this would save time. I think I spent far more time on this than I saved, but it was really cool. I vibe coded it, which was my first experience with vibe coding, and it worked. And it uses lasers, and it's, again, just fundamentally dumb, but it worked. So that's my donut measuring machine, which I spoke to a patent attorney, and he thinks this is more valuable of a patent than this, which is kind of fun. And then, as I said, just like the speaker, right, you build, test, and iterate. So this is a fundamentally silly thing, but the same engineering principles apply. Gathering your data, creating requirements, building, testing, iterating, prototyping. And then I patented it. So I have a provisional design and utility patent right now, patent pending. There's various forms that this could take, but these are the ones that we applied for, including spherical sports objects, which are balls, ping pong balls, golf balls. Doesn't have to be donuts. And then I did what I'm best at, which is design for manufacturing. So getting quotes for manufacturing. I quoted domestically, I quoted internationally, quoted with my local, like the companies I've worked with for years on Burrito Pop and big companies. And I found it fascinating, the discrepancy in pricing. At the end of the day, I'm going to use the cheapest one because I need to sell this as cheaply as possible. Tooling is $12,500 for something like this, and it's under $1 to make. That is a fantastic deal. Other vendors were giving me upwards of $80,000 a unit quote and $7 for plastic parts for domestics. So it was a really interesting comparison of, like, can we make it in the US? And the answer is no, not if you want to sell it. So I'm still trying to figure out when we can make things here, but it's not going to be on this donut holder. And then iterated on prototypes. So on the way left is a urethane cast. It's this really high-end cosmetic model. I played around with FDM printing right here, SLS, SLA, and just iterating and tweaking and coming up with these stupid videos. I then made packaging mock-ups. So what it might look like if you bought it at the store. And then I went to a Dunkin' Donuts and I put it down and pretended to buy it. And I had to tell the cashier that I made it. It's not yours. And he did not care at all. He was like, I'm not paid enough to worry about this. But my next door neighbor helped me create the actual die line and packaging and cut it out correctly. So leveraging some folks near me. And then my buddy created these renders of Steve Jobs with one, and that's the CEO of Dunkin' Donuts. And I made a device that allows you to like walk up and just press your hand underneath the button and dispense a donut. And then I tried my hand at social media content. I'm not good at any of this. I'm not good at making websites. I'm not good at any of this stuff. So this was my attempt, and took a long time.
Dear Duncan, I've lost control, but I trade me last pint for a donut hole. Click, pop, chew, load me up again. Click, pop, chew, with me sugared up friends. Click, pop, chew, no regrets, no shame. New England runs on Duncan and we all bleed glaze.
So that's a custom song that my friend made using AI, which is insane. And then I spent like 6 hours making that video, which I think 11 people saw on the internet. And I was like, all right, I'm done with this. But I learned a lot. And now I'm making beta units. I had an open call for people. If you want one, you can send me an email and I'll put one in a box and mail it to you. Again, I am losing money on this. I've yet to make any money, but I think it's just funny to me to know that there's a pilot in Salt Lake City who received one and he's using it at altitude right now. So what's next? We have no idea. Playing around with it. Obviously, I don't have a pontoon boat yet, or else I probably wouldn't be doing this. But yeah, we're trying to figure out what's going to happen with this. There's a local college doing a documentary on the behind the scenes and the pitch to Dunkin' Donuts. So there was a film crew in here the other day filming this, and they're interviewing my business partner Nate about it. So we have grand ideas, but we're hoping that Dunkin' comes through with an offer. If not, I would like citizenship in Canada, and Tim Hortons can have it. So that's the backup plan. So yeah, that's the kind of crazy fever dream side of things as well. Questions, comments, concerns?
I have another one.
Let's go.
Yeah, so actually you mentioned a couple of times the AI, so one for a song and one for the vibe coding. So, but interestingly, I don't hear a lot about AI in the product design itself. Are there any applications?
I would say no, honestly. I've played with these tools. As a mechanical engineer, I feel very confident that my job's safe for a while. All the AI CAD programs I've seen can do things like create a screw or create a bracket, which is one of 85 interrelated parts that need to be combined. But they can't create that entire thing yet. So I think AI is interesting. I think it's a cool brainstorming tool, like the vibe coding that I made for that machine. It works, doesn't work well, and it won't work forever. It'll break, and there's fringe cases, right? But it got me from 0 to 1, so that's great. When people come to me with AI product pitches or concepts that they've developed, renders, step one is we got to take a step back. That was really cool, what you've done, and it helped you figure out what you need. But now we need to take a step back and do it again, because we need it to be done by an expert who says, we're not using that microcontroller. That's crazy. We're going to use this one. Or doesn't need to be machined out of a block of metal like Apple does. Let's do injection molding and save you, $75,000 in tooling. Those are the kind of decisions that need to be made by an expert versus a computer, I think. So long story short, I think AI is really fun. I think it's a tool, but it's not a replacement. And I don't use it in any mechanical engineering at the moment. I'm proud to say that, I think.
Well, I have similar experience with electronics.
Yeah, like someone claimed to design a circuit board that booted Linux on the first try, but I don't think that actually happened. I don't see any proof of it. I think you could probably do a very small board layout, given 100 constraints. Maybe it'll work, but I don't think you're going to do your next iPhone with the control board for an iPhone with it, It may help you brainstorm and find components, but that's about it.
Dear guests, anything else? Or I will ask more questions.
Someone else. No, kidding.
Okay, Sam, let me ask you one more question. So,
Sure.
Few times recently, I have seen companies bragging about bringing a product, well, let's say bringing up a prototype within 90 days, 120 days. What does it mean? How do they set up a company to actually rapidly create new products?
So are they coming up with an idea in 90 days? Is it like 10 units?
Well, so they claim, yes.
Okay, so back to AI. I bet I could come up with a product in 90 days. I think I have, and I've done it. But a product is not mass produced and in hand yet, right? It's just the idea. It's a prototype. That's what they've done. It's not a product. It's a prototype. That's not hard to me. I think the hard part is, going from I can make 25 to I can reliably make 250,000. And that skill set is very different. But like Raspberry Pis, right? Or Arduinos, you don't see those in mass produced products most of the time, but they are used in prototypes. And so just that transfer of when do we switch over? Custom circuit boards, injection molded plastic parts versus 3D printed parts. There's always that transition over and that skill set change. So I think 90 days to make a prototype is great. And I think that's very doable. No one's making a full product in 90 days. And if they are, I think they're using the term product incorrectly, or maybe skipping.
They just have great marketing department.
Yeah. Or they're marketing to people who are like, that's awesome, I'll work with them. And then they'll be trapped. But I don't think it's 90 days to make a product. Unless it's a widget, like a plastic spoon or something.
All right.
I don't think that you can 19 days. Not realistically. Really not realistically. Unless you have a big factory with machining and 3D printers, 3, 4, 5 working simultaneously. 19 days.
90 days is
on paper. Oh, 90. 90 as well. No.
Yeah, that's tooling. Just to injection mold something is 6 to 8 weeks of injection molding timeline for tooling. So that's like buying the metal, cutting the tools, making your parts, testing, iterating. That's what 6 to 8 weeks is 60 days. So there goes 2/3 of it just getting the tooling ready. So very little time.
I don't know if you're familiar with metal extrusion. It takes at least 6 weeks as well. 4 weeks for die and 2 weeks for testing purpose on a supplier running this material before he will send sample to someone else.
Yeah, so I think it's good marketing is the answer, but it's not real.
On paper. On paper.
On paper.
Okay. Well, Sam, have a very best luck with the donut holder and the other projects.
Thank you.
Thank you very much for coming, and we will upload the video as soon as it becomes available on Google, probably within a few hours.
Great.
And I hope to see you again next time.
Thank you so much for having me. This was fun.
Thank you.
Thank you.